Hello everyone. In today's lecture, we are going to start with Module 3, that is Mining Frequent Patterns, Association and Correlations. Introduction. Frequent patterns are patterns that appear in a data set frequently. So these frequent patterns may be an item set, a subsequence, or substructure. Let us consider an example here. Example of a set of items such as milk and bread that appear frequently together in a transaction data set is a frequent item set. So any number of items that are appearing together frequently in any transaction history, that is called as a frequent item set. Now let us understand the definition of subsequence and substructure. A subsequence such as buying first a PC, then maybe a digital camera, and then a memory card. If it is occurring frequently in a shopping history database, that is called as a frequent or sequential pattern. A substructure, it can refer to different structural forms such as subgraphs, subtrees, or sublattices, which may be combined with item sets or subsequences. So, if a substructure occurs frequently, it is called as a structured pattern. And finding such patterns plays an important role in mining associations, correlations, and many other interesting relationships among the data. So this is what the definition of frequent patterns is. Let us start with a concept that is called as market basket analysis. Now, what is actually this market basket analysis? So this market basket analysis is a modeling technique which is also called as affinity analysis. It helps basically in identifying which items are likely to be purchased together. So, for example, the market basket problem, it may assume to have some large number of items like breads and milks, etc. So, customers buy the subset of items as per their needs, and marketer gets the information that which things customers have taken together. So, frequent item set mining leads to the discovery of associations and correlations among the items in large transactional or relational datasets. The discovery of interesting correlation relationships among the huge databases. This process also helps in many business decision making processes and customer shopping behavior. Example of frequent item set mining is market basket analysis. So what happens here is that it analyzes the customer buying habits by finding associations between the different items that customers place in their shopping baskets. Here is a pictorial depiction. Here we have a market analyst and we have n number of customer baskets, shopping baskets here. The main job of market analyst is to identify that which items are frequently purchased together by my customers. So as you can see here, we have basket number one. This is customer one, which has bought milk, bread, and cereal. Customer two's basket contains milk, bread, sugar, and eggs. Customer three basket has milk, bread, butter, and customer n in the basket we have sugar and eggs. So as you can see here, there are three items which are purchased together by customer one, whereas four items purchased together by customer two, three items purchased together by customer 3, and two items by customer n. So the market analyst is basically tracking the frequent patterns which are appearing in a transaction details. Market basket analysis. So here we consider a universe as a set of items available at store. Each item is Boolean variable representing the presence or absence of item. Each basket is represented as Boolean vector, and this can be represented in the form of association rules. So so for example, if a customer buys a computer, he tends to buy antivirus. So this support is 2%, and if the confidence is 50% here. So rule support and confidence are two measures here of rule in interestingness. So they reflect the usefulness and certainty of discovered rules. So here a support of 2% for association rule means that 2% of all the transactions show that computer and antivirus softwares are purchased together. And a confidence of 60% means that 60% of the customers who purchased a computer also bought the software. So try to understand this. A support of 2% means that 2% of all the transactions under the analysis, it is showing that the computers and this antivirus the software, these two items are purchased together. Whereas a confidence of 60% here means that 60% of customers who purchased a computer also bought the software. So typically association rules are considered interesting if they satisfy both a minimum support threshold and a minimum confidence threshold. Such thresholds can be set by users or domain experts. Now let us understand about frequent item sets, how they are denoted here. So here let let I is equal to f of I1, I2, IM be a set of items here, and D is the task relevant data. It is a database transactions. So I is a set of items, D is database transactions. The transaction is denoted by T, and it is a set of items. Each transaction is associated with an identifier which is called as TID. An association rule is an implication of the form A tends to B, where A is less than I, B is less than I, and A raised to B is equal to null. So the rule A tends to B holds in the transaction set D with support S. S is the percentage of transactions in D that contain A union B. The rule A tends to B has confidence C in the transaction set D, and C is the percentage of transactions in D containing A that also contain B. So this is taken to be a conditional probability P of B by A. Let us understand about support and count in more detail. So support, the definition says that the support of an item set is the count of that item set in the total number of transactions, and and basically it is given by support of A tends to B is equal to probability of A union B, which means that it is equal to, support is equal to number of tuples containing both A and B upon total number of tuples. Let us understand about confidence now. The confidence or strength of an association rule A tends to be, it is the ratio of number of transactions that contain A union B to the number of transactions that contain A. So confidence is equal to probability of B by A. So confidence is given as total number of tuples containing both A and B upon number of tuples containing A. So the rules that satisfy both a minimum support threshold and a minimum confidence threshold are called strong. An item set that contains k items is a k item set, and the set of this computer and antivirus software is a 2 item set. Here item set I satisfies a pre-specified minimum support threshold and confidence, then I is a frequent item set. The set of frequent k item set is denoted by LK. Okay, now we have to understand that how do we find this large item sets. So there are two methods to find the large item sets. Method number one is the brute force approach. In brute force approach, we find all the possible association rules, then we calculate the support and confidence for each rule, and the rules that fail the minimum support and minimum confidence are pruned from the list. But this step is time consuming, hence we have a better approach which is called as a priori algorithm. So we will discuss about a priori algorithm in the next slides. Okay, let us understand this association rule mining. So it is a two-step process. Number one, we find all the frequent item sets, and number two, we generate the strong association rules. There are certain improvement of the a priori method. Some of the major computational challenges includes multiple scans of transaction database, huge number of candidates, tedious workload of supporting counting for candidates. And a general idea over here to improve the a priori is to reduce the passes of transaction database scans. This is an algorithm of a priori. Here CK is the candidate item set of size k, lk is the frequent item set of size k, l1 is given as the frequent items. Now we check the condition here. For k is equal to 1, lk is not equal to null, and k plus plus. We begin. Ck plus 1 is the candidates generated from lk, and for each transaction t in database, we we do the next step here. Increment the count of all candidates in ck plus 1 that are contained in t. lk plus 1 is equal to the candidates in ck plus 1 with minimum support. We end this loop, and then we return the union of over here the other values. So other way to improve the efficiency of Apravra is hash based technique. So we will discuss this in more detail. So how can we further improve the efficiency of Apravra based mining? By using hash based technique. So what happens here is that a hash based technique can be used to reduce the size of the candidate k item sets, ck for k greater than 1. So when scanning each transaction in the database to generate the frequent one item sets L1 from the candidate one item sets in C1. Here we can generate all of the two item sets for each transaction, hash them into the different buckets of hash table structure, and increase the corresponding bucket counts. Okay, so yeah. In other methods here include sampling, dynamic item set counting. There are various kinds of association rules here, like mining multi-level association rules, multi-dimensional association rules, and quantitative association rules in maybe in traditional or relational databases. Okay, so we will stop here. In the next lecture, we will continue with this Apravra algorithm, and we will solve one example on it. Okay, thank you for listening.